Hi, Davenport students. Assume you're involved in Math 120, college mathematics now, and you're wanting a little practice help getting ready for the midterm. So we're going to go through the practice midterm exam, all 50 questions of it, in the space of maybe 2 or 3 videos, and give you all the help you need to prepare for it. So I assume you have the maybe it in front of you, but I'll put it here as well. Here's the first several problems. Here's a universal set, all the numbers from 1 through 10. A is 1 through 6, and B is 4, 5, 6, 7, and 8. And the first question we have is, what is A intersect B? So the intersection of two sets is, by definition, everything which is in both of those sets. So if you think of the universal set being like this, and this is set A, and this is set B, then the intersection is everything in there which is in both A and B. So the things that are in both A and B would be what? 4, 5, and 6? 4, 5, and 6. You can write them in any order you want, but we might as well just write them in numerical order. There you go. So there's the intersection. Okay? A minus B. What's that? A minus B is everything which is in A but is not in B. So A minus B, according to this diagram, would be all this stuff here. All this stuff which is in A but not in B. So in this case it would be what? 1, 2, and 3. Those are things that are in A but not in B. Okay? A, you know what? That actually should have been a union. We've already done an intersection, so I'm gonna do it the way we intended. A union B, and then the complement. Okay? A union B complement. So, so the union of two sets is everything which is in either one or the other or both of them. So here's the union of two sets right there. So let's just do that off to the side. A union B is everything that's in either A or B. So it would be 1 through 6. And then you don't need to include these again. They're already in there. But what else is also in B? 7 and 8. 7 and 8. So there's A union B. And now you want the complement of that. The complement of a set is everything from the universal set which is not in here. So it's everything in the here's the universal set. So it's everything in here but not in there. So it would be all this remaining things. So here's the universal set. You get rid of all this stuff, okay? So it's not this stuff, it's everything else. So everything else would be just 9 and 10 is all. Like so. There you go. So you first find the union, and then you say, okay, we want everything from the universal set which is not in the union, and so it would be that right there. The next one is A complement intersect B complement. Okay? So the complement of A is everything which is not in A. So here's A complement right here. Everything which is not in A from the universal set would be what? 7, 8, 9, and 10. Excuse me. B complement is everything which is not in B. So everything which is not in B, which is in the universal set, would be 1, 2, and 3. All this stuff is in B, and then also 9 and 10. Okay? Now that you have those two sets, you want the intersection of them. Recall that the intersection is everything which is in both. So everything which is in both is 9 and 10. And you look and you notice, oh, this is exactly the same answer as this. Is that just a coincidence or not? And the answer is it's not a coincidence. This is an example of De Morgan's law, something that we learned in the section, which is the complement of the union is the intersection of the complements. And so if you'd happen to remember that and you'd already done this one and you saw this one, you could have said, oh, the answer must be the same thing, because the as I say, the complement of the union is the intersection of the complements. Okay, I tell you what, as long as this other one was there, let's go ahead and do it. Let's do A union B complement and see what, oh, I'm sorry, not A union B, A intersection B complement. The complement of A intersect B. So we already have A intersect B, that's right here. That's 4, 5, and 6. And so A intersect B is 4, 5, 6. So the complement of that would be anything which is not 4, 5, and 6. So it'd be 1, 2, 3, not 4, 5, 6, 7, 8, 9, and 10. There's that one. And then if you remember the second one of De Morgan's laws, the second of De Morgan's laws from our section said that the complement of the intersection is the union of the complements. So this should end up giving us the same thing. Let's see if it does. First of all, what's the complement of A? The complement of A again is what? 1, 2, 3, 4, 5, 6. The complement would be 7, 8, 9, and 10. And then what's the complement of B? Complement of B is everything which is not in B, which would be 1, 2, 3, and then 9 and 10 again. And now if you take the union of these two sets, what's the union? The union is everything which is in one or the other. And again, I'll do it in numerical order. 1, 2, 3, 4, 5, 6. Here's the rest of them. 7, 8, 9, and 10. So there's the union of these two, and notice that these two sets are exactly the same again. So there's the other one of De Morgan's law. Very good. What's the next one asked? How many elements are in A cross B? Okay, so that's a totally different idea. Now we have this set which is A, and this set which is B, and now A cross B is all the, I'm going to make a great big thing like that. It's all the ordered pairs we can get by taking one element of A as the first element of our ordered pair, and then an element of B as the second element of our ordered pair. So here they all are. It's all these ordered pairs, kind of like points on a plane. So there's 1, 4. Let's go ahead and just do them in order. 1, 5, 1, 6, 1, 7, 1, 8. Okay, those are all ordered pairs. And then what? We can take the second one. 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8. Okay, take the third one. 3, 4, 3, 5, 3, 6, 3, 7, 3, 8. Okay, what about the next one? Just did that one. 4, 4, 4, 5, 4, 6, 4, 7, 4, 8. Okay? And you can do the same thing for 5, 5, 4, 5, 5, 5, 6, 5, 7, 5, 8, and finally 6, 4, 6, 6, 5, 6, 6, 6, 7, and 6, 8. Okay, there they all are. Now, I did them all because I want to make something clear to you. Notice that 4, 4 is one member of our Cartesian, called a Cartesian product. 5, 5 is one. 6, 6 is one. So when you just list elements in a set, then you would never list a number twice. You would never put 2 in there twice. You just put it in once. But here the order didn't matter. When you just have the elements of a set, this set here is the same as 2, 3, 1. All you're doing is collecting the elements, and it doesn't matter what order they are. Here, with a Cartesian product like this, then the order does matter. 2, 5 is a different element from 5, 2. I guess I don't have that one. Here's 4, 5 right there, and here's 5, 4. Those are two different elements, okay? Because this is in the first position here it's in the second position. And so the fact that you have a 4, 4, that's fine, because it means you have a 4 in the first position and a 4 in the second position. So so there's a Cartesian product, and or a product of two sets, and so all you have to do to find out how many are in there is you basically just take this number times this number, because you're just taking each one of these times all of these, and so you have 6 of them here. 1, 2, 3, 4, 5 there. 5 times 6 is 30, so you've got a total of 30 there. Okay, so that's a Cartesian product. Okay, very good. So that's all there is to know, or not all, I shouldn't say all, but most of the important stuff, actually. That's most of the important stuff there is to know about sets right there. Okay. Maybe the only other thing important about sets is that if you have two sets like this, and I shouldn't have erased it. A was let me do it again. A was 1 through 6. And B was 4, 5, 6, 7, 8. Then if you ask the question, what's the number of things in A? The number of things in A is 1, 2, 3, 4, 5, 6. What's the number of things in B? The number of things in B is 1, 2, 3, 4, 5. What's the number of things in A union B? Well, let's first take A intersect B. What's the number of things in A intersect B? It would be what? Just 4, 5, 6. Those right there. There's 3 things there. And then finally, what's the number of things in A intersect B? Well, what are the number of things in in A union B? It'd be 1, 2, 3, 4, 5, 6, 7, 8 of them. Okay, so that would be 8. And notice a relationship between these 3 things. The number of things in A union B is equal to the number of things in A and the number of things in B. So you add these together, that adds up to 11, and then you subtract the intersection, the number of things in A intersect B. Why is that? Because if you want all the things in the union, think of what you're doing. You're first taking all the things in A, and then you're taking all the things in B, but notice that you counted this stuff twice, right? You counted it twice, and so that's why you have to subtract the intersection, because you only want to count those things once. So there you go. Okay, so that really is about all the really important stuff from sets right there. Okay. What's the next one on our sheet? It says to simplify. This is number 6. To simplify, 2 times -5 plus -3 times -2 squared all over -3 squared minus 9. I've never seen so many negative signs in all my life. Okay, let's go ahead and simplify it. Well, let's see. 2 times -5 is -10. So I can handle that right there. Now I'm going to go plus -3, and I need to first simplify this before I multiply it by -3. So -2 squared is -2 times -2. -2 times -2's, the negatives cancel, and I just end up with 4. So this is going to be -3 times 4. On the bottom, notice that here you have the -2 is in the parentheses, so that means I square the whole thing. Here, I don't have the negative in a parentheses, so whenever you see something like this, you first square it before you take the negative. So this is going to be a negative, and then 3 squared is 9, and I'm going to subtract another 9. So you got all that. Now we can go a little bit further. This is going to be -10. -3 times 4 is -12. And then -9 minus 9 is -18. So you're going to get that. Simplify a little bit further. You're going to get -22 over -18. Now these negatives can cancel. And then I'm going to get 22 over 18. All these are correct answers, but you want it as simplified as possible. Let's divide both the 2 out of the top and the bottom. If we do that, we're going to get 11 over 9. And so that should be, hopefully, one of the answers. Yep, there it is. Okay, very good. Nice problem. Okay. How about number 7? Another one where you just have to know the order in which you do things. It's going to be 6 plus 7 minus 15, all in absolute values, plus the absolute value of -12, and then plus just a -35. Okay? So, you see this, and it said, and what you need to do is to first find the value of the thing in the absolute values. So 6 plus 7 is 13. 13 minus 15 is a -2. So I could simplify that and write it like this. Okay? Did I do that right? Okay. Now we can evaluate each of these. The absolute value of -2 is just 2. Okay? The absolute value of -12 is 12. It turns any negative number into a positive number. Okay? And then here we still have -35. So I should have equal signs here. 2 plus 12 is 14. 14 minus 35 is going to be -21. Is that an answer? Yep, I see it there. Very good. Okay. See this? All important stuff, all good stuff to know. All stuff that comes up various places in life. Number 8, which of the following is correct? Is incorrect. So the first one is 2 plus 3 over 4. Question is that equal to 2/4 plus 3/4? And the answer is yes. When you have a numerator like that, you can break up the numerator into 2/4 plus 3/4. So the answer is, I'll put a C for that's correct. So that's not the one we're after. Second one says we have 3 plus 5 times the quantity 7 plus 9, and the claim is that that is equal to 3 times 7 plus 3 times 9 plus 5 times 7 plus 5 times 9. Oops. And the question is that correct? Yes, it is. That you can get that by using what's called the FOIL method. Remember what FOIL is? FOIL stands for first, outer, inner, last. So if you multiply the first ones together, you get 3 times 7. If you multiply the outer ones together, the outer ones are 3 and 9. The inner ones are 5 and 7. And the last ones are 5 and 9. So using the FOIL method, we're going to get that. Another way of thinking about it is if you just take 7 plus 9 and multiply that by 3 plus 5, you just do every possible multiplication. You take 5 times 9 is 45. 5 times 7 is 35. 3 times 9 is 27. And 3 times 7 is 21. And you just add those all together. Those are the same thing you get here. Okay? Yet another way of thinking about it is if you have a big rectangle and here you have 1, 2, 3, and then 1, 2, 3, 4, 5. So here you have 3, and here you have 5. And then going this way, you have 1, 2, 3, 4, 5, 6, 7. And then you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, notice that the area of this rectangle is going to be, 8 by 16. Add those together, you get 16. The area of this rectangle is 8 times 16. But if I want to, I can break that rectangle up and say that area of that rectangle is composed of those 4 areas, and those 4 areas are 3 times 7, 3 times 9, 5 times 7, and 5 times 9. So that's how that all works. Isn't that cool? Okay. Let's make sure my computer's still working here. Okay, yep, I'm good. Okay, so anyway, that's correct. What about the next one? So, I guess for lack of space, we'll get rid of these two. See what the other ones are like. Next one says, is 2/3 times 4/5, is that equal to 2 times 4 times 3 times 5? Is that the way you multiply fractions? Do you just multiply the tops like that and multiply the bottoms? That seems pretty easy. Is it really that easy? And the answer is yes, it is that easy. Okay, so that's the way you multiply fractions. Okay, so that's fine. Next one looks at division. 2/3 divided by 4/5. And here the claim is that that's equal to 2/3 times, and it looks like what we've done is we've taken this bottom one and we've flipped it over 5/4. And then once we flipped it over, then we've done the same thing we did here. We're going to get 10 on top and 12 on the bottom. and or I guess the way it's written is 2 times 5 over 3 times 4. And is that correct? And the answer is yes. That's the way you divide fractions. Okay? So that one's good. Okay, well, shoot. Are they all right? Let's keep going. Next one says 2 times the quantity, 3 plus 4, is equal to 2 times 3 plus 2 times 4. Okay, is that correct? And the answer is yes. That's called the distributive property. It goes back to those rectangles again. If you have a rectangle which is 2 units here, 1, 2, 3, there's 3, and then 1, 2, 3, 4, there's 4, right there. Then notice that the area of this big rectangle is 2 times 7, right? This is 2, and this is 7, so 2 times 7 is 14. But if you want to, you can break up that rectangle into 2 parts. You can break it up into 2 times 3, which is this part, and then you can break it up into 2 times 4, which is that part. And so that's all good, okay? By the way, just to make it really, really clear, it is not the case that if you have 3 times 4, that's equal to 2 times 3, and then I guess you'd have a times 2 times 4. When you're multiplying things, here each one of these things was multiplied by 2. Here you just have 3 numbers that you're multiplying. And when you have 3 numbers that you're multiplying, it doesn't matter what the order of the multiplication is. But the point is you only have 1, 2, and 1, 3, and 1, 4. So it doesn't matter what the order is. You can write it as 2 times 3 times 4, or that's equal to 3 times 2 times 4, or that's equal to 4 times 2 times 3, any order you want. But the point is you only have 1, 2 in there, and you only have 1, 3, and 1, 4, no matter what. Okay, very important. Okay, what about the next one? Next one says 2 over 3 plus 4, is that equal to 2 over 3 plus 2 over 4? Well, we saw that it was true with the numerator. If you have 2 plus 3 over 4, we saw that we could just break up the numerator like this. If you have 2 fourths and 3 fourths, how many fourths do you have? You have 5 fourths, okay? So it makes it bigger. But notice that this one doesn't make any sense, because this number right here is smaller than either of these. Notice that. This is equal to 2 sevenths. And this one is 2 thirds, and this one is 2 fourths. So both 2 thirds and 2 fourths are bigger than 2 sevenths. So it doesn't make sense to break up a denominator like that into 2 pieces, okay? So that one is incorrect, okay? That one is incorrect. So there's the one that hopefully we choose. Let's just look at the last 2 just to make sure that those 2 are also good. This next one, it kind of gets at what I was saying earlier. Here you have 2 times 3 times 4 times 5 times 7. And the question is that equal to 14 times 5 times 4 times 3? And the answer is, well, let's see. I think all we did was we took 2 times 7, which is 14, and then what else is left to be multiplied? 5, 4, and 3, and it doesn't matter what order they all are, as long as you just use each one of these numbers once. We only used each one of them once, multiplied them in any order, and you're good. Okay? So that's fine. And the last one is a really important concept. This is important in all of mathematics. If A times B is equal to 0, I always tell my class, 0 is your friend. I have them say that as they leave the classroom together. Okay, 0 is your friend. Why is that? Because if I have A times B is equal to 2, these numbers could be anything you wanted. A could be equal to 1/7, and B could be equal to 14. Okay, and so 1/7 times 14 gives you 2. If B is equal to 2/5, then this one could just be times 5, and they all cancel. So all sorts of possibilities. They could both be negative, and they'd still multiply to 2. So any sorts of combinations will give you 2. However, if you put a 0 there, now you know something very important. These can't be just any old numbers. One of them has to be 0. So this means that either A is equal to 0 or B is equal to 0. You have two choices, but one of them has to be 0. So 0 is your friend. As soon as things are equal to 0, one of them's got to be 0. And that's why when you have an equation, x squared plus 5x is equal to 7, the way we solve that is first by taking the x squared plus 5x over and then subtracting 7 all over to one side, set it equal to 0, and then we can play with this thing and find out what, if anything, from there will give us 0. When will this be 0? Okay, so for example, let's just take an example. If I have x minus 2 times x minus 3, that gives me x squared minus 5x plus 6 is equal to 0. If I use FOIL to get all this, it's going to be x squared minus 2x minus 3x is a minus 5x. Negative 2 times negative 3 is positive 6. So if this thing is equal to 0, that means that this thing is 0. And then that means that if you have x squared minus 5x is equal to negative 6, okay, that means if you start with this, and you're trying to find out what values of x make that true, you can go backwards and write it like this. And once you have it in this form, now you can factor it and get this. And once you get this, now you can say I have two things, the product of which gives me 0. That means that either x minus 2 is 0 or x minus 3 is 0. And if x minus 2 is 0, that means that x is equal to 2. If x minus 3 is 0, that means x is equal to 3. So if you start with something like this, you always want to go back like this and find out what are the ways in which this thing can be 0. So that's why I say 0 is your friend.